Article 9.32 Shipboard Wiring Systems. Wiring for connection to systems of electrical machines and electronic equipment in various operations in watercraft shall comply with the requirements in the article. In addition to the applicable provision of Philippine Electrical Code, Part 1, Chapter 1, Flexible Cords and Cables, Chapter 8, Communication Systems, and Chapter 10, Tables. 9.32.1.2 Application. This section states that the requirements written under Article 9.32, together with the other applicable rules of the Philippine Electrical Code or PEC, must be followed when installing permanent electrical wiring systems on ships or watercrafts. So, any wiring used for electrical machines or equipments on ships or watercraft must follow the rules in Article 9.32 of the Philippine Electrical Code, along with other related PEC chapters. It states that these standards are required when installing permanent electrical wiring systems or any type of watercrafts. Article 9.32.2.1 Cable Construction. Electric cables of recognized marine standards shall have conductors, insulation, and moisture-resistant jackets. A. Material of conductor. Conductors shall be made of copper not less than 1.0 mm in a cross-section and stranded in all sizes. B. Types of cable insulation. All electrical cables utilized in watercraft wiring systems shall be insulated as outlined in C. Fiber optic cables. Fiber optic cables shall be constructed and tested to a recognized optic cable construction standard. The requirements of flame retentancy for the electrical cables is applicable to the fiber optic cables. The construction of the fiber optic cable shall be such that the escape of gases to a safe area is not possible through the cable. So, conductors must utilize copper with a minimum cross-sectional area of 1.0 mm to ensure adequate current carrying capacity, and they shall be stranded for flexibility and durability. All electrical cables in watercraft wiring system must be insulated, ensuring safety and reliability in wet environments. Cables constructed with the Type T insulation may have insulation thickness indicated below. When a moisture-resistant nylon jacket is provided on each individual insulated conductors, minimum voltage rating for this cable is 750 volts, and the minimum average thickness of the Type T insulation and nylon shall be as specified in the Table 9.32.2.2. So, as we can see in the table, cables constructed with Type T insulation featuring a moisture-resistant nylon jacket on each insulated conductors must possess a minimum voltage of rating of 750 volts with the average thickness of both the Type T insulation and nylon jacket. Cable insulation testing and outlines the procedures for testing the insulation of cables, including grounding, immersion in water, and applying specific voltage and frequency. Dielectric strength test describes how to test the dielectric strength of the cable insulation to ensure it can withstand high voltages. While insulation materials classification classifies insulation materials into Class A, Class B, and Class E based on their composition and maximum operating temperature. Cable insulation resistance for new installation. Each power and light circuit must have a specific insulation resistance between conductors and between each other conductor and ground. Class F insulation materials like synthetic resins with a glass of mineral reinforcement typically used for transformation windings can operate at temperature exceeding Class A insulation but not exceeding certain limits. Class H installation similar to Class F but for higher temperature ranges. Insulation resistance of cables must meet specified values determined by applying test voltage. Propulsion cables, ethylene, propylene, cross-linked, silicone rubber, or approved cloth insulated cables are used, except that polyethylene or cables cannot be used if the operating temperature exceeds 50 degrees Celsius. Moisture resistance jacket and metallic sheath are required. Distribution cables must have insulation suitable for temperature not less than 60 degrees Celsius, with the insulating materials being degrees Celsius higher than the maximum temperature likely to occur. So in this table, rated cable voltage, this column indicates the cable's rated voltage for both AC and DC systems. Test voltage for 5 minutes. Alternating current specifies the test voltage using a alternating current that the cable must withstand for 5 minutes, while direct current specifies the test voltage using direct current that cable must withstand for 5 minutes. For example, a cable with a rated voltage of 0.15 or 0.25 kV should be tested at 1 kV AC or 2 kV DC for 5 minutes. Battery cables must be protected with pipe coverings or shielding and sealed to resist electrolyte ingress. Cable should handle the current at the starting rate of charge. Control cable should have at least 3 strands and be smaller in cross-section than power circuit, except for automatic control directly connected to main circuits. Generator cables must be of an approved type, comply with propulsion cable requirements, and not be installed in the same channels with other cables. Switchboard wires must have flame retardant and moisture resistant insulation not less than 1.25 mm and be suitable for temperatures up to 75 Celsius. Wiring from hinge panel should be extra flexible and PVC insulated. Instrumentation circuits insulated wires for control and instrument circuits should not be bounded with wires for main circuit unless voltage and temperature ratings at the same time. Cables for power and lighting. Mineral insulated cables with approved fittings can be used to 600 volts in exposed, concealed, dry, or wet locations. Feeders and subfeeders. Feeders and subfeeders of any description shall be constructed as far as practicable to be considered exposed to damage such as encountered when passing through manholes, tunnels, and excavation. Branch circuit. Branch circuits shall have insulation suitable for a temperature of not less than 60 degrees Celsius. The temperature is insulating material must be 10 degrees Celsius higher than the maximum temperature likely to exist or to be produced in the space where the cable is installed. Cables for essential services. Cables for essential services are important for the propulsion and safety of the vessel and shall be flame retardant, mechanically protected, and corrosion resistant. A separate insulated shelf shall be provided for every motor required for essential services. Essential services that are required shall be served by individual circuits separated throughout their lengths as widely as practicable, and use of common feeders, protective devices, or controls circuits. Cables shall be connected to the most electrical equipment, terminals, panel boards, or power and lighting, and control panels for navigating lights, special purposes lights, and to navigation aids. The following are examples of essential services. Air compressor for engine starting. These compressors provide the compressed air needed to start the main engines of a ship. Air compressor for heavy oil and for tanker washing of holds. Heavy oil. Compressor supply air for systems that handle heavy fuel, such as fuel automation for combustion. Tanker washing of holds. This compressor provides the necessary air pressure for the tank cleaning system, which uses high pressure water jets to clean the cargo holds of tankers. Air pumps for general use. This pump supplies compressed air for various purposes throughout the ship, including pneumatic tools, control systems, and other auxiliary equipment. Ballast pump are used to move seawater into and out of ballast tank. Ballast tanks are crucial for maintaining the ship's stability and trim, especially when it's not fully loaded with cargo. Bilge pump. Remove accumulated water from the bilge, which are the lowest compartment in the ship's hull. Brine pumps are used in refrigeration system to circulate brine as saltwater solution to transfer heat. These systems are vital for cooling cargo provisions and air conditioning. Cable for non-essential services shall be rated not less than the minimum and maximum current the cables are designed for. Cables associated with installing safety circuits shall be used only for such circuits and shall be physically separated from cables associated with non-intrinsically safe circuits. Cables for explosion-proof equipment. This lead in part of cables for explosion-proof electrical equipment shall be a type of suitable for watercraft cables. Consideration shall be given so that the cable can be rigidly secured. Lead in part, except where the cables are installed in enclosed room, oil pumps room or space housing oil tank shall be lighted by aesthetically safe explosion-proof lamps, and cables shall be secured by cable clips. Only approved armored cables run through grating should be used with stuffing glands and inlet and outlet. Cables for alternating current. Generally, in easy installations, the wiring shall be made with cables. In certain cases where it is necessary to use single core cables for AC circuits, the following precautions shall be observed. Single core cables, non-magnetic materials. Cable should be either non-armored or if armored, it shall be a non-magnetic material belonging to the same circuit. When installed in pipes or conduit, cables belonging to the same circuit shall be contained in the same time pipe or conduit. 2, 3, or 4 single core cables. When installing 2, 3, or 4 single core cables forming respectively single-phase electrical circuits or 3-phase and neutral cables, the cable should be in close contact with each other. In every case, the distance of external covering of two cables shall not be greater than the diameter of clips securing the conductor shall be insulated unless made of magnetic material. Installed against steel bulkhead. When cables are installed against steel bulkhead, ventilating fans for machinery spaces, engine, and boiler rooms must follow specified guidance in related sections. Ventilating fans for gas dangerous areas for non-gas dangerous rooms must be installed in a manner that considers these factors. Winches and windlasses shall follow appropriate wiring methods for safe operation. Pass-through steel plates. Where single-core cables pass through steel plates, all cables of the same circuit shall pass through the same steel plate and be constructed in such way that a suitable material is provided between the cables and the cable core and magnetic material. Glands for passage of cables. Glands for the passage of cables through bulkheads and decks shall be of non-magnetic metal. In addition, they must become necessary components and have cable seals of sufficient size to obviate the heating of cable. Skin effect on additional losses. In estimating the size of cable, it is necessary to take into account the skin effect and additional losses in and armors and the effect of bulkheads. When cable nuns pass along metallic plates or through bulkheads of magnetic metal, impedance of circuits of considerable length of image across section and crossing of single core cable shall be as far as possible equalized for this purpose. The pace may be transposed at interval not exceeding 15 meters or any other appropriate methods can be used. This requirement is not necessary when the length of the runs is less than 30 meters. Cable of the same pace. In the case of circuits including several cables in parallel per pace, the cables of the same pace shall be as much as possible alternated with those of other paces. Multi-conductor cables. Multi-conductor cables shall be mounted on supports. Single conductor cables. Single conductor cables may be used for power distribution provided the following arrangement are complied with. A. Cables may be supported of non-fragile insulation. B. Protective metal covering if provided is grounded at the middle. C. Three-piece cable circuits around each of three pieces shall be separated. D. Single conductor cable shall be used when carrying single-phase load. Cables for emergency alarm and fire detection. Cables for emergency alarm and fire detection circuits shall be arranged to provide signal machinery spaces and other spaces having a high risk with circuit that work whenever necessary to provide services to protect personnel when these spaces to detect fire occurrence. Cables for communication. All cables for communication shall be either lead sheeted, mineral insulated sheeted, or armored or non-mineral sheeted, or out of O2 retardant type. Electric cables shall not be installed in dangerous zones or spaces, except as permitted in the section and those associated with aesthetically safe circuits. Exposed to cargo oil, oil vapor, etc. All cables which may be exposed to cargo oil or oil vapor gas shall be sheeted with at least one of the following. 1. Copper sheet for mechanical protection. 2. Lead alloy sheet plus further mechanical protection. 3. Non-metallic impervious sheet plus armor. Where corrosion may be expected. Where corrosion may be expected, non-metallic insulation shall be applied over metallic sheets and around cables. Against mechanical damage, cables installed on deck and on or off firm mini air gasways shall be protected against mechanical damage. Avoid strain or chafing. Cable shall be installed so as to avoid strain or chafing, and due to allowance shall be made for expansion or contraction and for the movement of the structure where expansion benefits are fitted. They shall be accessible for maintenance. Pass-through gas-tight bulkheads or decks. Where cables pass through gas-tight bulkheads or decks, separating dangerous spaces or spaces from the other dangerous spaces or from spaces not intended for human occupancy. Cables shall be installed such that the gas high-tight integrity of bulkhead or deck is maintained. Installed in heavy gauge steel pipes. Cables installed in pumps rooms shall be suitably protected by installation in heavy gauge steel pipes or other equivalent means. Used in safe circuits. Cables be installed shall comply with section 9.32.2.5 and those used in hazardous areas or explosion-proof type. Distant from decks. Cable shall be installed sufficiently distant from decks, bulkheads, tanks, and other kinds of pipe. Close the hull centerline. Cables shall be installed as close to the hull centerline as practicable. 9.32.3.2 Electric Propulsion Systems. Essential for maneuvering or maintenance. Cables essential for maneuvering or maintenance of propulsion power shall be stranded, having a nominal cross-sectional area of not less than 3.5 mm. Slip rings of synchronous motors. Cables which connect the slip rings of synchronous motors shall be suitably insulated for the voltage to which they are subjected during operation. 9.32.3.3 Cargo ships with spaces for carrying vessels with fuel other than diesel oil in their tank. Certified safe type. If electrical cables and the detection system are located within the cargo hold, they must be of certified safe type as is enumerated in standard. Terminating in cargo hold. All cables terminating in the cargo hold shall have suitable moisture length isolation seals to prevent entry of oil. Provision shall be made for means of off-position. This does not apply to flame-proof devices such as fire, smoke, or gas detectors or motors. Automatic and remote electrical control system. The cables and console wiring for the automatic and remote electrical control system comply with the following. Adequate voltage rating and ampacity. Cable for power supply and wiring associated with the control system shall be of the listed types of adequate voltage rating and ampacity. Flame retarding type. All cables and wirings in control and monitoring circuit shall be of the flame retarding type. Properly supported. Cable and wiring harnesses should be properly supported and securely fastened to avoid vibration and movement. Unsheathed and unarmored. Cables used within control console need to be sheathed or armored. Shielded. Cables for monitoring and control circuit may carry low-level or informational signals must be shielded. Left of hoist shaft. Supplied from main switchboard. Left of hoist shaft shall be supplied from the main switchboard either directly or through a subboard or switchboard and provided with suitable protection for electrical circuits and motors. Mechanically protected. All cables other than power cables passing through left or hoist shaft shall be enclosed or protected with strong metallic material which mechanical protection is required such as armored cables and shall be not placed within the same conduit. Motor cable and flexible traveling cable. Cable supplying the left of hoist shaft shall be of the flexible type and should be adequately protected to ensure safety. Tankers intended for the carriage in bulk of oil cargo having a flash point below 60 degrees Celsius. Closed cap test. Cofferdam adjoining cargo tanks. Electric depth surrounding devices. Electric depth surrounding devices should be located clear of the cargo tank bulkheads and be provided with cables installed inside heavy gauge steel pipes with gas-tight joint up to the main deck. Impressed current cathodic protection systems. Where impressed current cathodic protection systems are fitted, cables for the connection must be installed in heavy gauge steel pipes with a gas-tight joints up to the main deck. Permanent ballast tank. Cables passing through permanent ballast tank. Compartments filled with seawater must be protected with corrosion-resistant pipes to adequate mechanical protection. Other cables. If cables need to pass through cofferdams adjoining cargo tanks other than those supplying the equipment described in 1, 2, and 3, these shall be installed in heavy gauge steel pipes with gas-tight joints to the main deck. Cargo pump room. Same requirements as in A above. High voltage cables. Mechanical protection. High voltage cable should have a metallic sheet or armor. The sheet or armor must be electrically continuous and provide mechanical protection. The metallic protection shall be of the proper thickness to protect the cables from the mechanical damage. In open areas, cables should be provided with a continuous metallic sheet or armor which is effectively bonded to grounding systems. Not run through accommodation spaces. High voltage cable should not run through accommodation spaces. Segregated from cables lower voltage. High voltage cable should be installed as far as practicable away from the cables carrying lower voltages. Identifiable. All high voltage cables should be readily identifiable by suitable marking. Circulating currents. Where single core cables are used, precaution shall be taken against circulating currents in the sheet or armor, and the cable shall be transposed at intervals about 16 meters. Adequate space. All high voltage equipment shall be designed and located such that adequate spaces are provided to ensure efficient cable termination. Barriers. Wherever practicable, all conductors should be effectively covered with suitable insulating material. In terminal boxes, if conductors are not insulated, pieces shall be separated from ground and from each other by subdivisional barriers of suitable insulating material.